All right, here is page 500. We're doing volume of prisms and cylinders. Name the figure that describes a regular container is a regular hexagonal prism. The base is a hexagon and it's a prism. If the area of each filter paper is B, or base area, write a formula that finds the volume of filter paper. So volume equals base area times the height. So we have a bunch of hexagons stacked up H times. So if we want to find the volume, we have to find the area of the base. So the area of a regular hexagon is 1/2 the apothem times the perimeter. Or, and so we have our hexagon here, we can draw another side here. And since we know that all the interior measures of a hexagon are 120, because of this formula, we know each of these 120, we cut it in half, we get 60, this is 60, so it's an equilateral triangle. And we have 6 of those, so we can use our equilateral triangle formula, s squared root 3 over 4, so it's 4 root 3 over 4, or root 3, and there's 6 of those, so times 6, 6 root 3 is our base area. Or, this is a 60-degree angle, we drop our apothem, our perpendicular, it's a 30, 60, 90 triangle, our radius is 2, half that is our short leg, 1, and that times root 3 is our long leg. So 1 times root 3 is root 3. And so the area of this triangle is 1/2 the height, root 3 times the base, 1, so root 3 over 2, and there are 12 of these in there, so 12 times root 3 over 2, which is 6 root 3, or just our apothem is root 3, our perimeter, each of these sides is 1, so the side of our equilateral triangle is the same as our radius, so 2 times 6 is 12, our perimeter is 12, and we get 6 root 3. So the volume is our base area, 6 root 3 times our height, 4, so 24 root 3, or 41.6 inches cubed. Couple different ways to find this, but you need to be able to find the area of a regular hexagon. Letter B, if we change the radius and triple it, what happens to everything else? Well, our radius now is 6 instead of 2. That means all the other measurements of this triangle triple. So if we're using 1/2 the apothem times the perimeter, instead of root 3, it's 3 root 3. Instead of 12, it's 36. Multiply that out, we get 54 root 3. Our height is still 4, so we multiply that, 216 root 3. If we want to see how much it changed, we divide those two, and it's 9, so we got 9 times bigger. Because we changed 2 dimensions, 3 times 3 gives us our 9 times bigger. All right, just a review of what a right cylinder and oblique cylinder looks like. The height is the distance between the two bases, perpendicular distance. Cross section of each cylinder, if we cross parallel to a cylinder, the circles are congruent to the bases. The area of a circle, because the area of a cross section is the area of a circle, pi r squared. The base area is the same as the area of a circle. That's the same. It's kind of a weird question. So, a prism and cylinders are similar, except for the bases. In a prism, the bases are polygons. In cylinders, the bases are circles. So it's still base area times height, but now we know the base area is the area of a circle, so pi r squared. The volume of a cylinder is pi r squared times the height. If we have a problem where they give us the volume and the diameter, so divide that by 2 to get a radius of 4, what is the height of the cylinder? So we plug it in our formula. The book divides to find h first. I like to put in the numbers first. Either way, we get 8.95. We're going to round to 1 decimal place or the 10th spot, so 9.0 feet. We do the same thing for A, B, and C. Volume of a cylinder is 220. The radius is 5. What's the height? We plug it into our formula. So it's 220 equals pi times 5 squared times h. Divide by pi, divide by 5 squared, so 25. We get a height of 2.8 centimeters approximately. Letter B, the volume is 90. The circumference of the circle is 27. Determine the height. So first we have to find the radius. Circumference is 2 pi r. So we divide by and that equals 27. We divide by 2 pi. Our r, our radius, is about 4.3. So we substitute that in, and it's just like problem A. Volume equals pi r squared times height. Divide by pi and r squared. We get that our height is about 1.55, so 1.6 meters. Letter C, we're back to prisms, so it's the volume of the base area times the height. Volume of the base area in a rectangle is just width times length, or length times width. So we got our width 15, length time is what we're trying to find, and our height is 4. So we divide 120 by 15 and 4, we get 2 feet for our length. Just working backwards using our formulas. Now if we look at these 2/10, finding the volume, well, this first one is half a cylinder. So it's 1/2 our volume of a cylinder formula, 1/2 pi r squared h. So if we find it, 1/2 pi times the radius 3, radius is 3, the diameter is 6, and the height is 8. The height is from base to base, which are these semicircles. We get 113.1 feet cubed. If we look at tent B, this is an isosceles triangle. So we find the area 1/2 base times height. The base is 6, the height is, or the base is 5, the height is 6. Multiply it, we get 15 feet squared. The volume of the tent B is base area times height. Our base area is 15, our height is 7, because again, that connects our two bases, the front triangle, the back triangle. So it's 15 times 7, 105 feet cubed. Which has a greater volume? Obviously, tent A, 113 is greater than 105. Now, if we look at the surface area, tent A is a little confusing. We have 2 semicircles, make up 1 circle. We have the bottom that they're going to be sleeping on, the 6 by 8, and then we have this rectangle that wraps around it. So if we take our regular formula of a surface area, 2 pi r h plus 2 pi r squared, we have to cut those in half because we have half a cylinder. But we have to add in that other rectangle, which is 2 times the radius times the height. 2 times the radius, so 6 times the height, 8, will be this rectangle that we're going to be sleeping on. So this is our formula. We plug in radius and height. Again, this is the rectangle. That's the lateral rectangle. This is the 2 bases. And this is the bottom rectangle. So plug in R and H, we get 151.7 feet squared. Perhaps let's draw a net of this. So we have our bottom, that's a rectangle. We have our semicircle, another semicircle, and this is what wraps over top. So radius is 6, 3. This is 8. And so this is half our circumference. Half of 2 pi r. And so is this, because this wraps around the semicircle, which is just pi r. And that's what we were doing here. All right, the shape of the bases of tent B, we have an isosceles triangle, so we got to find this side by Pythagorean theorem. 6 squared plus 2.5, which is half the side squared, equals our hypotenuse squared. We solve it, we get 6.5. So surface area of tent B, the perimeter of the base, so 6.5 plus 6.5 plus 5, so 18 times the height, which is 7, plus the 2 bases, those are both 15, so 30, add those up, 156 feet squared, which has a greater surface area, tent B. So if we compare these two, which has the greatest volume with the least amount of material? Well, I think we're looking at tent A. And our homework is going to be page 504, numbers 13 through 17.